Welcome back to Physics Clinic at the Red Rose Academy. Now that we have understand the concept of division of complex numbers and learned how to rationalize the denominator using the conjugate of a complex number, it's time to put our understanding into practice. In the next part of our class, we are going to work through some important NCERT exercise problems based on complex number. As we solve each problem, don't just focus on getting the final answer. Pay attention to the method, the concept, and the shortcuts we use. Okay, so take out your NCERT book, math book, keep your notebook ready, and let's see how well you can apply what you have learned. Okay, let's begin with the first NCERT question right now. So we'll solve this. So what is this question? It is from your NCERT book. Express the following complex numbers in the form of a plus ib. Okay, so 3 times 7 plus 7i, I times 7 plus 7i. It is the first one. You need to multiply all these things and then segregate real number separate and then complex number, imaginary number separate. This is very simple. You can able to understand. 3 7s are 21, 21i plus 7i plus 7i square. That will be negative, right? So -1. So it will be, okay, here it is negative only. Okay. Then 14, or here it should be negative. Then it will be positive. Okay. So 14 plus 28i, like that you have to do. So here also you can multiply 1 times -1, minus of -1, that is +1. So minus of -1 minus I. Then you can multiply 1 into 6i. Okay. Then minus of I minus 6i. So it will be like this. Okay, so 6i minus I will be -7i, 1 plus 1 will be 2. Like this, you have to, you should multiply and shuffle everything. Okay, multiply and rearrange into a real part and the imaginary part. That's it. Okay, so if it is I power minus 39, I already taught you like 1 by I power 39. So write in a multiple of 4 and then write the remainder separately. So it will be 1 times I power 3. So it is equal to minus I again. Like that, you have to find out. So again, minus I should be in the denominator. Then minus of 1 by I will be minus 1 by I. Okay. So make sure you know the denominator should not contain any I. So that if there is any I terms in the denominator, you should multiply, rationalize the term with the conjugate. So the conjugate of I will be I alone. So I by I. So 1 into I minus 1 into I is minus I. By I into I square is I square. So minus I by minus 1, that is equal to plus I. So that is the answer. So suppose if you find, while just expressing the following given thing in your book into a complex number, if you find any I in the denominator, definitely you should rationalize with the conjugate. Okay. Then here also solve the following expression and find real and imaginary parts. Okay, so the upper one is addition, the numerator and denominator is addition. Based on addition rule, you can add 3 plus 3 is 9. Okay, plus root 5i minus 5i. So that will be what? So root 5i and minus 5i. So how can you do that? So both are I only, but inside what is there? Root 5 minus 5 into I. Okay. By 3 plus 2 is 5. And minus 2i plus 2i gets cancelled. Then you can write like Okay. Sorry, 3 plus 3, it is 6. 6 by 5 plus root 5 minus 5 by 5 into I times. So it is real part of Z, it is imaginary part of Z. Okay. So this is how you have to represent. Then we'll see multiplicative inverse, that is reciprocal. We know Z is equal to 1 by Z. Then if it is Z is equal to A plus IB, what is the reciprocative inverse? 1 by Z. So 1 by A plus IB, I told you the rational number, I mean the complex number or the imaginary number iota should not be comes under the denominator. If it is there in the denominator, you should multiply with the conjugate and rationalize the term. So what is the conjugate of A plus IB? A minus IB. So rationalize the factor. So A minus IB by A plus B into A minus IB means, you know, A square minus B square. So A square minus B square, you can use it. So since I square comes, I square will be minus 1. So minus into minus will be plus. So the resultant will be plus A square plus B square. So the top numerator will be A minus IB. Then you can write the real part and the imaginary part separately. A by A square plus B square minus I times B by A square plus B square. So this is the form you have to write. And suppose if you are asked to find the multiplicative of this, you can write 1 by 4 plus 3i. So 1 by 4 plus 3i is the conjugate is 4 minus 3i. So 4 minus 3i in the numerator, denominator 4 square plus minus 3i square, 3i the whole square. So minus I square will be plus 1, right? So plus 3 square. So 4 square plus 3 square will be 25. And 4 by 25 and 3i by 25. Like that, you have to separate, I mean, real and imaginary part. Then if you are asked to find the multiplicative inverse of 2 plus I root 3, then how can you do? So what is 2 plus I root 3 the whole square? So you have to expand first in the form of A square plus B square plus 2AB and then simplify into the form of the real number. Got it? So otherwise you can't able to find out. Keep this tip in your mind. So what is Z inverse here? Z inverse is 1 by Z. Okay. After that, you know how to find, right? So this is the only tip you have to keep in your mind. If it is whole square, use the normal identity, normal algebraic identity, and express it in the form of the complex number. And similarly, if it is cube also, you have to do the same. Okay. Then these are all the identities of the real number and complex number. You know all these identities of the real numbers. The same like the complex numbers identities also for square and cube. Okay, keep this in your mind. Then, students, if you want to take a screenshot, you can take a screenshot. Then express 5 minus 2i whole cube in the form of a plus ip. I told you, no, whole cube means you have to form in the formula. You can use the whole cube formula. What is the whole cube formula? A cube plus b cube plus 3a squared b plus 3ab squared. Like that, you can use all the formula and then express it in the final result. You have to express, simplify the term in the form of complex number, and then you should find the 1 by z, that is the inverse of the number, and make sure it should be multiplied by the conjugate and rationalize the term. See here, you have to express it as in the form of a plus ib, like this. Okay. See, how can we write? See, for example, here. So express negative 2 minus 1 by 3i the whole cube. So what is this? You can take minus outside. Okay. So minus 1, the whole cube, it's taken outside, and inside it will be 2 plus 1 by 3i the whole cube, right? So all negatives are you have taken outside. So minus 1 the whole cube will be minus 1. Then after that, it's easy for you to utilize, apply the formula 2 cube. You just expand it based on that. A cube plus b cube plus 3ab square plus 3a square b, like that. And then simplify and write it in the form of a plus IB. So when looking at it, it's very easy for you. But by doing, don't commit any mistakes in plus or minus. Okay, so that is very important. So if there is a fraction, so you need to add fraction in a very right manner. I can able to say even a grade 11, 12 students also fail to do this kind of fractional addition. So very important, just keep your concentration in it. Then we'll move on to the modulus of complex number. What is the modulus of complex number? If there is a complex number, you need to take the square of the real part plus the square of the I mean the sum of the square of the real number and the square of the imaginary number in a root. So that is abbreviated as modulus of z. So find the modulus of this, means real part, imaginary part, and then do, okay, take the square and sum it and then put it in the root. Okay. Same like it is having its own property. Okay. So modulus has its own property. Take a note of this. Z1 plus Z2, the whole modulus is less than or equal to Z1 modulus plus Z2 modulus separately. Like that, addition and subtraction also. And then Z power n, the whole modulus can be written as Z the whole power n modulus. Like that also we can able to do. Then this is the triangular inequality, less than or equal to Z1 plus Z2. Okay, so it is given some example. Okay, Z1 is given. You can find the modulus. Z2 is given. Find the modulus. Then add that individually. Then add these two numbers. Okay, and then simplify that. And after that, find the modulus. So that will give you. So after simplifying this, then find the modulus. So and find out, see, there is indifference between these two. Okay. So definitely Z1 plus Z2, the whole modulus will be less than the Z1 modulus plus Z2 modulus separately. Okay. So it is very important. Less than or equal to. Okay. Then it is not in your syllabus, it seems, but we'll see this argument and everything for JEE mains. Okay. So right now we'll focus on NCRT. Then modulus and argument of Z, it is given. Okay. It is like a by B model. So here, definitely you should not find any imaginary number in the denominator. Multiply with the conjugates. You will be getting this. Then after that, you know how to write. Okay. It is the usual method of doing conjugate. After simplifying this, you have to find the modulus. Okay. So this is what you are doing. Okay, comparing with z, x plus iy. Okay, x is less than 0, y is greater than 0. Then from this argument also you can able to do. So argument I'll teach you later. Okay, so for JEE mains focus. Then this is conjugate. Okay, conjugate you know. So for conjugate also you'll be having this property. Okay, whole conjugate, like what you studied for modulus, the same you had to learn for this. And z dot z bar will be z square, modulus of z square. Z bar is the conjugate. If minus 6 minus 8i is the number, and its conjugate is minus 6 plus 8i. Okay, then modulus of z can also be written as modulus of z bar. So it is also can be written. Got it? So this is what you have to understand. Z dot Z bar. Like, okay. Then what is Z modulus? This one. Okay. So keep this in your mind. And find the real numbers x and y if this is the conjugate of this. Okay, it's very important and interesting. And then this is the conjugate of this, it is given. This number should be equated to this number means what it says, this is the conjugate of this number. What is the conjugate of this number? Plus, right? So you can write it as plus. Okay, because it is a conjugate of this, so you can write it as plus. Okay, and then do simplify. and then equate the real term and the imaginary term, and then you'll find x and y. Okay, is it clear for you? If you didn't change this to conjugate, definitely the answer will be going wrong. Okay, keep in your mind. Then, in which condition the additive inverse and the conjugate of complex number will be equal? So this is also very interesting topic. What is the condition? Okay, z is equal to x plus I